Today's lesson is reciprocal functions.
You don't know your times tables, Caleb?
Consider the function f of x equals 2x plus 3. It's just a nice line. Whee! Nice little line. There we go. Okay? What we want to do is we want to look what happens when we take the reciprocal of it. Now, the reciprocal of it means that we're going to look at 1 over f of x. 1 over f of x means 1 over 2x plus 3. We want to see what the graph of that is going to look like, okay? So, in order to do this, here's what we do. We locate the x-intercept of the line. And I want us to draw a nice asymptote at that value. You might, when I say the word asymptote, do you know what I'm talking about? Have you heard that word before?
Like an animation video, yeah.
Okay, so here's what an asymptote is. So I'll write that down and then I'll explain what it is. This is one example of an asymptote. An asymptote, the analogy I'll use is it's like a high-powered electric fence that nobody in their right mind would touch. So the function is like a curious child who might go closer and closer and closer to it, but they will never touch it.
Are those F or E? F or P?
A-S-Y-M-P-T-O-T-E.
Okay.
Asymptote. So what happens is, what we do is we flip this upside down. So what's 1 divided by 1? 1. So what I always do is I always look for where y is equal to 1. It's right here. That point is not going to change. But everything else changes. Because if we look right about here, what kind of number is this? Okay, and if I get closer and closer and closer, what happens to the number? What happens to the value of y as I get closer and closer to the asymptote? That goes down. Gets smaller and 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 smaller. What's 1 divided by a really small number? A really big number. So what's going to happen is, as you get closer and closer and closer to the high-powered electric fence, the graph is going to get higher and 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 higher. Like that. And as the graph gets bigger, like it does going to the right of that red dot, what's 1 divided by a really big number? Really small number. So then the graph is going to get smaller and 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 smaller. But 1 over anything, 1 over a massive number, still not going to be 0. So the red line the red curve that I just drew in is still not going to touch the x-axis. It's going to get infinitely close to the x-axis, but it'll never touch it. So actually, the x-axis also acts as a horizontal asymptote. The graph will never touch it either. Now, we're not done because that was just to the right of the asymptote. We're going to do the same thing to the left of the asymptote. This time, instead of locating 1, we're going to locate -1. And actually, I got to back up here. I really got to back up here. I know it's Friday, but this isn't 1. This isn't 1, so this is my mistake.
Oh,
Feel free Feel free to interrupt me when I make a mistake like that, please. 1 is right here. So all we're going to do is we're going to massage this graph a little bit and make sure to draw it in a little nicer like that, and then like that, and then nobody knows. Okay? Unless you use pen, but you probably shouldn't do that when we're drawing graphs anyway.
Can you zoom out a bit so I can see those numbers?
Zoom out or in?
Out, so I can see those numbers in the corner there. That's what I was trying to write down.
We're going to locate -1. I'll find this one on the first go, I promise. It's right here. And then what we're going to do is we're going to see these values here get really, really small. So it's 1 over that will be a really, 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 really big negative number. A really big negative number will tend towards negative infinity like this. And then it'll get closer and closer and closer and closer and closer to the x-axis, but it'll never actually touch it. So the red graph of what I drew in is the reciprocal of 2x plus 3. And the asymptote is at x equals minus 3 over 2. That's the equation of the asymptote. You should label the equation of the asymptote on your graph.
Why isn't
How do we know that? Great question. Because this is 1, -1. This is -2. What's halfway between -1 and -2? -1.5. What's -1.5 as an improper fraction? -3 over 2. So that's why the equation of the asymptote is x equals -3 over 2. If we were to figure out the domain of this function, the reciprocal, I mean, it would never equal -3 halves. So the domain for this function, and this is kind of just, I'm sure we'll do this later, but the domain of this function would be negative infinity up to -3 over 2, round bracket, because it can't equal -3 over 2. And then we put a little u, which means and, -3 over 2 all the way to positive infinity. Round brackets all the way around. That would be the domain for this reciprocal function. And the range would be very similar, except instead of -3 over 2 being that cutoff value, what would be the cutoff value?
What is that in the middle of those two brackets?
It's a u. And it means it's both of those things together. So the range would go from negative infinity up to, but not including, 0. Union, 0, all the way to positive infinity. That's your range of that function. So as my grade 10s who sit in this room with you, they always ask me, do we always have square brackets when we get to certain numbers? The answer is no. And here's an example of where you wouldn't have square brackets. Because neither the domain doesn't hit -3 over 2, and the range doesn't hit 0. Okay, now, when we did the absolute value on that quiz, by the way, I marked that quiz, number 2 on the quiz gave you an x and a y value and said what would be the x and y value of the corresponding absolute value function. And the only person that got that right is Mr. Matheson. All you do is change the sign on the y value to a positive.
Nice, man. You got the second question.
Now, when you take the reciprocal of a function, x doesn't change, y does. And this just summarizes what we talked about. Small y values become very large, Large y values become very small. Y values of 0 create asymptotes. And signs don't change. Even if a big number becomes small or a small number becomes big, positives remain positives and negatives remain negatives. So let's do a couple examples. Draw x plus 1 and 1 over f of x on the same set of axes. So x plus 1, that looks like this. Okay, it's hard for me to draw on this, so I'm just going to... All right, that is f of x. That's just x plus 1. That's a line. We learned to do that in grade 10. No big deal. Now, we're going to graph 1 over f of x. I got to ask you, where is the asymptote? At what x value? Where is the asymptote? It's -1 because you look for where the graph is equal to 0. It's equal to 0 right here. So we draw an asymptote at that value.
Oh, this is plus 3, right?
And we write down the equation, which is x equals -1. And then we just go ahead and draw in the reciprocal function. So I find out where 1 is. See, I spotted 1 this time, or you can't see it quite yet, but I spotted 1 this time. I didn't make the same mistake again. And really small values are going to become really big values. And really big values are going to become really small values. And that's how you graph the right half of that. Now to graph the left half of that, well, -1 is that anchor point again. And really big values become really small values. And really small values become really big values. So the blue graph I just drew in was 1 over f of x. So that's how you graph a function and its reciprocal. You look for the x-intercepts. The x-intercepts become asymptotes. Then you look for those anchor points of 1 and -1 and create curves just like we did. Are there any questions? So even though, so actually the red graph I just drew over here is the reciprocal function. We've talked about the absolute value function. We've talked about the quadratic function. These are all the mother functions we've looked at so far. And here's another one, the reciprocal function 1 over x. Okay? All right. So here's one that kind of does exactly what I just... Ooh, this is interesting. This is interesting. And I'll just... I don't want to make anyone manic on a Friday, so I'm just going to give you a spoiler alert here. There's no asymptotes here. And let me show you why. So, we're focusing on x squared plus 1. X squared plus 1 is a beautiful parabola that has a vertex of 0, 1. And we know how to graph it. We would just go over 1, up 1. And every grid square horizontally is every 2 grid squares is 1. So we have to be careful about that. then we go over 1 up 3, and then we go over 1 up 5, and then over 1 up 7. This goes back to our unit on quadratics. We go over 1 up 1, over 1 up 3, over 1 up 5, and over 1 up 7 to find our additional points. Now, if you're talking about this point, that's the vertex. And from here, I see that the x-coordinate of the vertex is 0, and the y-coordinate of the vertex is 1. Because there's no number in the bracket here with x, it means it's 0. Okay? So we'll generate our points to the left. 1, this one, this one, this one. So right now we're not doing the reciprocal function. Instead, we're actually graphing the base function of x squared plus 1. So another wonderful connection from what we've done previously in this class to what we're doing right now. So I just drew f of x in red. So to draw the reciprocal of this, it's not super nice or fun or awesome, but really what we do is we find that anchor point of 1. The anchor point of 1 is right here. Let me use blue, it'll stand out more. The anchor point of 1 is right here. And as the graph gets much bigger and bigger and bigger and bigger, my reciprocal is going to get much smaller and smaller and smaller and smaller. So it's going to go like this. With never touching the x-axis. That's better. And you're going to do that on both sides. And there we go. That's how we graph y equals 1 over f of x. So you might be given the graph of a function, and then you can graph the reciprocal by creating asymptotes at any x-intercepts, and then going from there. All right. We've got a fun-looking graph looking right. Go ahead, and we are going to sketch the reciprocal of this. How many x-intercepts do we see? 1. Where is it? X equals? -3. So we're going to draw an asymptote there.
Wait, what if you have more than one x-intercept?
Then there's more than one asymptote. The next one. Oh no, the next one doesn't have it. I could show you one. That's not a huge deal.
No, we don't got time for this.
So
3316, spend the lesson.
now let's look at where the 1 is. Where the 1 is, because that's our anchor point. Going to the left is going to be easier because there's just not much of it to the left. The anchor point is going to be right here. And then from there, we get a little bit bigger, but not much bigger.
And we know the anchor
And then
points are y.
the anchor point's always 1 or -1. Because 1 divided by 1 or 1 divided by -1, it doesn't change.
And it goes down, so-
I didn't like the curve I just drew, so let me try it again. Because the graph only goes down to -2, 1 over 2 is a half. So the graph should stay at about a half all the way across. Now, if it got super big, then we go super small, and we go right down towards, but not touching, the x-axis. But it only gets down to -2, and 1 over negative 2 is a half. The anchor point on the other side is a little bit more complicated simply because it's all these values here. It's everything in that little strip. Okay? So what that means is, when we graph this, it's going to go, as it goes towards the asymptote, the values get smaller. So our values are going to get bigger. And over here, these values are getting bigger. So these values are going to get smaller up to about here. And it's super hard to do this, but it doesn't get any bigger at this point up here. So we have to try and just level off at that point. Not that it's really easy to show a leveling off point. It really isn't. And then we'll just put an arrowhead there. Now, I did forget one thing. I forgot one part of this. Can anyone see the part I forgot? What's that? Yes. And also, we didn't go down from here. So let's do that. Good for you. You're more on the ball than I am. There we go. And we'll label the asymptote. The asymptote is x equals minus 3. And there we go. There is our graph of the reciprocal function. Because this is minus 3. This is where the x-intercept is. It's always where the x-intercept is. Because 1 over 0 is undefined. We don't know what 1 over 0 is. But you might have a little bit more knowledge of what 1 over 0 is if you take calculus in university.
Amazing.
Okay. There. We're one final example. One final example. Here we go. The graph of a reciprocal function in the form 1 over f of x equals 1 over ax plus b is shown. So it's right here. It asks you to find the graph of the original function and determine the original function. So let me ask you this. It's going to be a line. It's going to be a line. Where is the x-intercept on the line? Negative 4, because that's where the asymptote is. So I'm just going to go ahead and make a scale here. Say that's 10, 10, negative 10, negative 10. And at negative 4, I know that's my x-intercept. What else do I know? And this is where it gets fun. If we have a point 0 and 1 over 8, then that means that the reciprocal of that, the only thing that changes is the y value, and you flip the y value upside down, and it becomes just plain old 8. So you flip 1 over 8 upside down, find the reciprocal of it, and you get 8.
I know, X is like here and then Y is like here.
So now we have 2 points. The x-intercept is negative 4. The y-intercept is 8. Connect the dots with the ruler, and that's the graph.
Yes, you're right.
That is where the asymptote is. So that tells us that's where the x-intercept is.
How do we know where to start with that line?
Well, we knew that it was here, because the asymptote's here. The asymptote is where the x-intercept is.
I'm a little.
Diagonal.
This line?
No.
Well, because we figured out this point. Because here
Writing that.
we have the point 0 and 1 over 8. So to find the reciprocal of 1 over 8, you flip it upside down and you just get 8. So it's not 0 and 1 over 8, now it's 0 and 8. So that's this point here, it's 0 and 8. Once you have 2 points on a line, then you just connect the dots and Bob's your uncle.
5 would be 13.
Now the question asks us to find the original function. The original function would be y equals 8 plus 2x. That would be the equation of that line. We are not going to do a quiz or a homework check on this. This is just a practice. Your review for this test is all afternoon on Monday. All afternoon on Monday.